Okay, let's go ahead and do tutorial 5 here. First thing I'm going to do is right click on this and save link as and put it in electric. It's already there, but we'll do it anyway. And then start electric. And I've got the tutorial printed out here, and I'm going to try to follow it as best I can. Okay, let's pull this up, put this over, pull this down, tile it, select the window, whoops, almost hit F9, which pauses my video. Alright, so adjust position. Yeah, good enough. Now let's open tutorial 4. And then let's go to save it. File, save library as tutorial 5. Okay. And first thing in the printout says to make a new schematic view of a cell, Control N, called Inverter underscore 4P, where the 4P means that there's going to be 4 inverters in parallel, and whoops, don't want that. Let me see if I can change view to a schematic. Alright, so let's just delete that. Delete cell, yes. New cell, let's get schematic this time. Inverter underscore 4P. I think that when you use a change view, it's for the group. If you select the group or one of the icons and there's another view and you hit change view, it'll pull you into that view. Okay, so the first thing it says is grab the, let's do it this way. Cell inverter and put 4 of those in there. So we did it that way. Let's go ahead and do it this way. And then Control C, Control V a couple times. And we get 4 inverters. So this is just one way of putting 4 down. Now let's create a new version of this cell. And so we right click on this and say create new version of cell. So they're the same because there's only 2 versions here. So now it says to delete the top 3, select the bottom one, and go up to Edit Array. Where's Array? There it is, or F6. And let's go with a repeat factor in the Y direction of 4, and no overlap. We can hit Apply. And up pops our 4 inverters because we arrayed them in the Y direction. And they're abutting, so we instantiated one of the inverters and then we arrayed it, and now the inverters are abutting. Well, we might want them to be spread out, so we need to specify an overlap. So we'll grab this bottom one, hit F6, and let's go the long route. Slows me down a little. And array, and let's set the Y overlap to -5, meaning they don't overlap. The minus sign indicates they're spaced apart. And we get our inverters. And now this, we can use the array command in in schematics, but there's other things that are better instead of arraying a large number of objects in a schematic. So we generally don't use array for schematics too often. So let's go make another version of this cell. Now I right clicked on this cell, the one we're in right now. So if I right click and say create new version, you'll see the original version I had, the one we just used the array to generate so everything's nice and straight, and then the new one. So let's go delete those cells now. Let's select this one, Control I, and let's put it right on the origin. Okay, hit fit, expand a little. And now what I'm going to do, in order to specify 4 of these inverters in here without having to array or put 4 of them in, I'm going to do a Control I. And then I'm going to change this to inverter, and let's just call it 20. You can pick whatever name you want. 10, and then an array of 4 elements, 0 through 3. And we could pick 1 through 4, or 5 through 9, etc. Okay, and then let's use Control and click and pull that up here. So now we have 4 inverters. So these schematics, all 3 schematics are exactly the same. So we need to connect wires to this icon. So if I go here, let's go make sure we have a wire arc. I go here and I put a wire arc there. It connects all 4 inputs together. And that may be what you want, but in some cases it's not. So instead of doing that, let's go back, select the bus arc, and pull it out like this. So there's my bus pin. That's the node that's selected. And then in order to get access to all 3, I can name the bus here. Let's just call it N0:3. And so now N0 corresponds to inverter 2010-0. If I would have selected N1 through 4, then N1 would correspond to the first inverter, N20-N_20_10-0. Let's go put a pin down here, and then come over here, and then let's label that bus out, and I pick some different name just so it's not always 0 through 3, 12:15. And so the input of one inverter is N0, and its output is out 12. N1 connects to out 13, N2 connects to out 14, N3 connects to out 15. And so now we have access to each of these connections. So now the next question is, how do we connect to the bus? And so we could go back into the wire mode, and let's see, select that and come down. But that doesn't tell us which pin in the bus we connect to, so I've got to label that. So I'll just double click or Control I it and call that N0. So I can connect to a bus pin, I can connect a wire arc to a bus pin, or I can use a junction. And the junction I pick right here, and then I'll come over here, go back and select the bus arc, select there, come in, makes the connection, and then I can go select the wire arc, come down here, and then connect to one of them using out 12. Okay. And so those are the 2 ways. And of course, if I wanted to connect to more than one, there's a pin. I could add another pin if I wanted to. Oops. Control Z. Go back over here, select that arc, and now I've got 2 pins I can connect to. Okay, let's Control Z so we stick with the tutorial. Let's go to Edit, Clean Up Cell, Clean Up Pins Everywhere. Okay, so let's go make our ring oscillator now. So let's do a Control N. Make a cell called ring, what do they call it, oscillator, and it's a schematic. Okay, let's go drag my cell in here, and let's make our ring oscillator a couple of different ways. Let's go use F6 or Edit Array, and let's put no repeat factor in the Y direction. Let's make 11 of these inverters in the X direction, and let's leave no overlap there, and let's set the overlap there to -5. Okay, fit. Now I've got 11 inverters, and so now I could go and select the wire arc and connect it all up. but that will take a little bit of time. So what I'm going to do instead is I'm going to go to Tools, Routing, and you have to be careful here because if you don't turn this off, you're going to get all kinds of crazy behavior that you may not want. Enable Mimic Stitching, so it's going to copy. So when I go from out to in here, it's going to connect all the out to ins in the other places. So I'll come back around, go to Routing, and disable Mimic Stitching. And then drag a wire like that, and then label this node Oscillator Out. And of course we won't be able to see it, so let's zoom in there. Use Control to click. And then what size do we set that text to? In the tutorial it says to set it to 5. Hit OK. Fit or fill. Alright, let's do an F5 just to check. No errors. We're ready to add spice code. Okay, so let's drop that in here. Query it. Change its size to 5. Go to multi-line and copy BDD 0 DC5 dot tran 030N dot include C : /electric /C5 underscore models dot txt. Hit save. Okay, we're ready to simulate. So let's go to Tools, Spice, Write Spice Deck, and Oscillator Out. Let me just verify I don't automatically delete raw files. Nope. Alright. And then Electric's Waveform Viewer will come up. Go to Explorer, .tran, Oscillator Out. Looking good. Of course we can zoom in and all the other stuff there. Alright. Alright, so let's make a new version of this cell and do it the other way, which is to use the arrays. So let's go to Ring Oscillator, create new version, and let's move this over here, select its text size to 2. OK. Delete. Delete. Pull that up. Delete that last wire arc. And let's go make 11 of these. And let's call it something different. What did I call it in here? Inverter 1 through 11 or 0 through 10. OK. Control click. Then come over here. Over here. And then what do? We'll call the input of the first inverter is Oscillator Out. And then we'll just call the output of the first inverter Out 0, and the output of the 9th inverter, or 10th inverter, Out 10. Wait, let's see, Out 9. The output of the 10th inverter will be Out 9, yeah. And then over here, we'll call this Out 0 through 9, Oscillator Out. Okay, so this means the if you remember, the input of the first inverter, let's go back and look. The input of the first inverter is oscillator out. Its output now is out 0. The output of the last inverter is oscillator out, and its input is out 9. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? So we're ready to simulate. Let's pull this up a little. Say save. And we didn't simulate in the tutorial, but we'll do it here because it's easy. Looking good. Looking good. All right, we're ready to make the layout of this cell. So this is where the arraying will come in handy. So let's do an edit and then a new cell, new cell, and then layout, ring, oscillator. Okay. And then pull that down here. Yeah, that's good enough. And then let's go up to cell or edit, F6, array. And we don't want any, we want them to abut. So we want 11 instances of that cell. Say OK. Hit fit. And we can show what's inside if we want. Okay, there we go. We can DRC it, no errors. Let's go ahead and hide it. Now, we can enable the mimic stitching, but it doesn't work too well here, and I don't know if it's because I didn't specify the type of nodes or what, but instead I'm just going to go and connect everything up. It only takes a second. Left click, right click, etc. It's even faster for the grounds because it's just a bunch of right clicking. So left click, right click, right click, right click, right click, etc. Again, you can try the mimic stitching. You can always hit Control Z. And let me see what order I did the tutorial. Did we export or did we put the... Alright, let's DRC it. Looking good. Okay, we didn't export the VDD yet, so it says next thing to do is to put the metal 1, metal 2. Let's zoom in so I can see. Yeah, that looks good. You know what, while I'm here, I'll do that. A little bit out of order just to save a little time. Come down here. Right click, and let's move this up a little. Let me do a Control Z's and just move it up. Now do it. Okay, so let's go back here. Select metal 2, hit fit, come over here, and then F5 it, and then we need to Control click until we get to this node, and then hit Control I, and call that oscillator out. Of course, we won't be able to see it, so let's zoom in there until we can see it. Change its size to, what size did I say to change that to? 10. Oops. Fit. Okay. So last but not least, let's DRC it. We need to do exports here so that the well check works. So let's select that port, Control E, VDD. Select this port, Control E, GND. Okay. Zoom on down. Query. Let's make it size 10. Scroll down here with the mouse button, the roller bar. Make that size 10. Okay, fit. And then let's DRC. LVS. And well check. Alright, everything's looking good. The only thing we have left to do is simulate. So since I don't want to type all that stuff back in, let's go grab this. And let's go grab it here. It's a little bigger. Control C. Control V. And what size do we change the text to? I guess it doesn't matter. It's good enough as it is, but let's make it a little bigger. 10. Okay. Now, before we simulate, so let's do the LVS one more time. LVS, well check, F5, let's hit save. So the layout and the schematic match. So here's the schematic, here's the layout. And I want to point out one more thing here. If I go to Preferences, Tools, Spice, here, when I do my layouts, I can simulate with the transistor areas and perimeters, so it takes the source and drain areas and from the layout puts those in. Or I can get an RC simulation for the parasitics of the metal wires, the resistance, the capacitance to substrate poly, and the metal wires. In either case, when I compare this simulation results to what I get with the schematic, my simulation, my oscillation frequency is going to be lower. And so you can compare that, but let's just show, and you can look in the tutorial and verify that this is the case. That's the case, and you see, sure enough, the oscillations frequency is lower. And this is just a good point to make sure you simulate the layout. And of course, you know, there's special tools that do a full-blown layout extraction with simulations, but you can get a pretty decent estimate, especially in this half-micron process, when you use the conservative RC. The problem is it takes longer to simulate. All right, let's save this and go ahead and quit. And let me, since I'm going to do the last tutorial later today, let me just close this library and then come over here and stop.